So what I'm going to show you now is an application that we use in-house to manage our business. It's called Olympus. Olympus is one client application into our own system. So we use this to run things like our staffing operation, our magazine business, our customer databases, our anything, your invoices, anything we do as a business goes through the system, and Olympus is one of the apps we have that runs that. And I like to show that because it's an older app, and so it's kind of a cool real-world example of how you can add that to existing information. We also have web clients and mobile client companion pieces that are going in, but people for some reason like using this Windows application. And so we can come in here, and one of the features that I like to show is our article database. So this is where we maintain articles that we have written for Code Magazine. And I always pick this one article. I'm not sure why I'm always picking the same one, but it's just one that I have been using. And you could look at this article online. So here is that article that was written by our editor, Rod Paddock, and it goes on the website. And it was printed in the magazine at some point. It's a really old article, actually. In fact, we can see here that the abstract says this is Rod Paddock's July-August '06 editorial. Doesn't tell us much about what it is, but I had some editor go in and actually put in this description. So when somebody goes into an article search and we show a list of articles, we can at least show some information about what that is. But we also have the actual article content, which we maintain in Markdown. So that's the actual article, and this is a preview of how it will appear on the web. And what we can do here now that's kind of cool is we can bring up a Copilot. And this Copilot here uses a sidecar-based approach. So we built a Copilot into our old application, and we can now do things like some of these predetermined shortcuts, which is always nice to have in a Copilot interface. So when I click this thing, it goes and it actually sends a request into OpenAI and into one of the language models, and it says, please generate me an abstract. It gives it all this text here as part of this prompt. So rather than saying, hey, how are you doing, I'm saying, hey, here is an abstract, give it all the text, or excuse me, here's an article, I give it all the text, and then I say, pretend you're a technical writer who understands technical content. Create me an abstract for a technical audience, and then give me the result. And so it gave me this result here, and I could now say, oh, this is cool, or change it a little bit, or in this case, I'll just say accept it, and it then sticks it in here, and now I have a much, much more meaningful and in many cases very accurate information or very accurate abstract about this particular article. So that's awesome, right? And I could now tell it, no, this was not good, do it again, come up with a slightly different version, come up with a longer or shorter version, make it more or less exciting, all those types of things. But it's now feasible for me to create abstracts for all the articles because it can comprehend, think about that for a moment, it can comprehend what's in our article content. And I could do other interesting things, like let's start a new Copilot session here, and I could do something like I could say, do we have any similar articles in our database? And I know it's hard to read, but I'm reading it out loud here. Do we have any similar articles in our database? Question mark. And I hit enter. And what we now do is we have to detect the intent. So unlike the other one where we knew we just used, okay, the content of the article that we already had, and now had to comprehend what the content of the current article was to understand what a similar article would be. It thus then came up and said, okay, similar articles would be about T-SQL innovation, SQL Server language replacements, things like the CLR and link queries and so on. So we used this system of a large language model to detect the intent of the user's question in combination with the current article content. We could then go into our database of articles using Azure Cognitive Search in our case, or something like Amazon's Elasticsearch. We then retrieved all the articles. We then took the abstract of, or the content of all these articles, create a large prompt, a large piece of text that says, okay, here's all the articles we have, here's the current articles, here are the other ones. Now answer the original question, do we have similar articles? And it then comes up with this answer. and it says, hey, we have these articles, and I even integrate that, and that's an important piece. I'm integrating it with the host application, so I can click on one of these guys, and now I can bring up this article and see, well, what is this article about? Oh, it's SQL Server. Okay, that's cool. That's clearly related. I could also say things like, why is the first article on the list? And it will then give me a reason, and it knows the overall context of what we are talking about, and it'll give me a reason. It says the first article discusses the conclusion of the author that T-SQL should be replaced due to several developments, blah, blah, blah. So it goes in and it gives me a technical explanation of why it thinks those two articles are related. Okay? So think about what I've just shown you here and think about how you would code this without AI, and how, again, 6 months ago, this would have been complete science fiction. Okay? And there's a question online, would it be hard to train a custom model on all the articles and have a conversation about any topic within the article database? No, well, that's not trivial, and we wouldn't train a model. You do not retrain large language models, because I don't want to spend $250 million and build 5 large warehouse-sized data centers to create a language model that takes 9 months to train, which would be completely infeasible for the obvious reasons, but also we publish articles all the time. I can't have a 9-month training phase when I publish something daily. So what we do instead is you can fine-tune a model, which is kind of additional training, but even that we don't do here. What we do here is we retrieve additional content and then inject that into the prompt with a technique called prompt engineering. And this prompt engineering is a general technique, but then also pulling content in and stuffing the prompt, so to speak. That's called retrieval augmented generation. It has this horrible acronym of RAG. But that's what we're doing here. And so with that, yes, we can absolutely have it reason over anything we've ever published. And that's essentially what we're doing here. Now, a lot of people say, well, you got really lucky, because what you have in your database is articles, and articles are all about language. What we have, and what most people have, is rectangular data. We have data in a SQL Server database, an Oracle database, something like that. And we want invoices with line items and so on, and we wanted to reason over that. You can't do that, can you? Well, I'm glad you asked, because let me show you another example. So here is our interface we use to query people. So I could go in here and say, what data do we have about myself? And here are my records. I have several different records in our database, and I could now drill into it and see all the things that we have on record about myself. So here's loading that record, and that has a lot of information. It has my addresses and categories I'm in, and subscriptions I own, and magazines I got, and events I attended, and articles I wrote, and invoices I got, and then so on and so on. You get the idea, right? So there's probably 20, 30 tables involved, or maybe more, with all this information about myself. So how do I reason over that with the Copilot? So we built in this Copilot here, and I can do the following. I can say, what customers do we have in the database from Microsoft who attended any of our events and or have a magazine subscription? Okay, now think about that. How would you do that in a world without AI? How would you even come up with a query, or how would you provide an interface that allows your customers to query that, right? But we have our database in SQL Server. We also created an index over that that is just in sync with our database in SQL Server. Now, we could have probably also gone directly into SQL Server, but it's a lot easier if you have some kind of intelligent search index. In our case, we use Azure Cognitive Search also for this on top of our rectangular data, so that's doable. So I can now use this to get all the people from Microsoft that have attended any of our events or magazine subscriptions. Now, if I do that, obviously I have a little bit of a data privacy problem if I show you those names, but I can do something like this. Replace all the actual names with fake names. Okay, because it's a language model and it will understand. And so now we trigger that and it detects the intent. Oh, we want to look for something that includes magazine subscribers and event attendees, and they are from Microsoft. And now it goes into our database And it comes up with this list, okay? And so it comes up with 14 people that are both event attendees and subscribers from Microsoft. And by the way, it's fine for me to show these names because note at the bottom it says, please note that the names provided are fake names because I instructed it above to only, replace everything that looks like a name with a fake name. Well, that's kind of cool. Like, how would you, it's a language model. It can be intelligent. And so that's kind of cool, right? And now I can say, provide a list grouped by event and then show each attendee first name only and add was active magazine subscriber at the time if they had an active subscription at the time they attended an event. So I wanted to match names to events, show me a list of events. Underneath it, show me the first name, which it sometimes gets right and sometimes doesn't. I hope it does because then I can show you something further. And then I wanted to match the time and date that they attended the event and then look in our magazine subscription database and determine the range on which they had a start end date on which they had a subscription. So did they have an active subscription at that point in time when they attended the event? So let's see what it does with that. And you'll notice that I don't trickle in the response here. That would be an option which would UI-wise be nicer, right? So it comes in and we see it. But we don't want it to do that. We just wanted to show the result. And here it is. Here's the result, and it did it correctly. So we know that, for instance, this Psy person, which is a fictitious name replacing the original name of the customer, it still remembers that. And they came to this State of .NET Microsoft Web Development event and was an active subscriber at the time. Other people like Mike attended this event but was not an active subscriber at the time, which is why it didn't add that. Think about what you've just seen. We were looking on the fly using a Copilot AI. We're looking on the fly into live data stored in SQL Server that we had a search index over. We then match that. We consider probably 20, 30 tables in the process. We create a meaningful result that matches the intent of the user, the intent of which we detected using an artificial intelligence. We thus came up with this context that it can then use. And then all the rest of the functionality we've just seen is essentially emerging behavior. I didn't code the ability to hide the real names. I didn't code the ability to understand matching event with a subscription date range that indicated they were active. That is emergent behavior that we get because we're dealing with something that to some degree is intelligent. Now think about that. How would you have done that again 3 months ago? Absolute science fiction. And now we could even do stuff like we could say, what do you know about the first person in the list? Speak in the voice of John Cleese of Monty Python. Feel free to be funny. And again, it's this, I never coded this into it. It's just emergent behavior that results out of that setup, right? So, oh yeah, indeed, we have here in the database the one and only blah, blah, blah. I must say, sounds like quite the active magazine subscriber, oh boy. Attending events, keeping up to date with the latest developments, good show, jolly good show, and so on. It's now pretending to be John Cleese making a funny statement about this person, but still based on factual data from within our database, although I instructed it to not actually use a real name, which is nice because otherwise I couldn't demo any of this to you. And so I don't know, maybe I'm easily excited, but if you really think, if you think through what it takes to build that, I think your mind should be justifiably blown. And this is very doable. This is doable within your own applications. I'm not saying it's super easy,